I told you guys I would do a little bit of a review. I'm not going to do all of these problems right now in the video. I'll do like every other, something like that, or I'll do a bunch of them. But we are going to go over everything that is going to be on your test whenever we have it. The sections P1, P2, P3. It could be next Tuesday. It could be the following Wednesday. I don't know. We'll roll with it, like I said, once, we see what Hurricane Dorian. Once Hurricane Dorian makes his appearance, we'll see what happens. There we go. Okay, so anything that I talk about today on this video is fair game for your test. I will give your quizzes back when I'm done. If you guys have any questions, you can ask me, whatever. But all of this stuff is going to be on there. So we need to know these things. In this first section here, 1 and 2, I'll do the first one. We talk about what kind of numbers that we're looking at. If you notice, the first and the second questions are practically the same. If I have the whole number 16, what is the most specific name that I can give the whole number 16? A natural number. Good. Natural. What about negative 16? Integer. Why is it not a natural number? Good. Very good. What about square root 16?
Whole. No, it could go to 4.
Okay, whole. It is a whole, but if it's just positive 4, what could it be? Natural. A lot of you on your quiz made that mistake. I did not mark it completely wrong.
Whole is including 0.
Mm-hmm. I did not mark it completely wrong, but as soon as you saw a radical, you were like, oh, it's irrational. Or, oh, it's rational. Think about what the square root of 16 is. What is it? 4. If you could simplify it, then you have to do that. What about the square root of 2? It is irrational. Good. Those weird square roots are irrational. What about 8 over 3? Rational. Our fractions are rationals. Good. And then think about this. Okay, you guys see it's a fraction, so immediately you think rational. But look at the fraction. It's negative 8 over 4. 8 over 2. What is that? It's an integer because that's really negative 4. Good. Make sense? Okay, we could do all of these together in about 2.3 seconds. What's the property? 3 plus 2x equals 2x plus 3. Commutative. The number order moved, right? It commuted. What about I have, my nose is itchy. A plus B times A minus B, or A minus B times A plus B. Commutative again. It's the same numbers, but what did they do? They moved. All right, what about here in 5? What happened with A times x plus y and then ax plus ay? Distributive. Very good, guys. And then what about a plus 1, x plus y, and then a plus 1 times x and a plus 1 times y? Distributive. Very good. Questions? We were pretty good on those. All right, I will do all the b's here because it gives me a little bit of room. You guys will have adding, subtracting, multiplying, and dividing fractions. We're getting better at it, which is a positive. When I'm multiplying and dividing, do the denominators matter? No, but adding and subtracting, they do. Okay, so we have to have a common denominator. What's the common denominator between 6 and 3? 6. Very good. So I have 5 minus, 3 times 2 on the bottom is 6. So 2 times 2 on the top is 4. Yes? So I simplify to 1/6. Questions? No? Okay. If I have 7/10 plus 11/15, what's the common denominator between 10 and 15? 30. Sometimes you don't see that. It doesn't jump out. What did I tell you could do with the denominators if you just were trying to find a quick way to simplify? Multiply them together. You could have done 150. Your problem would have been bigger. You'd have to simplify at the end, but 30 works easier. So if I change this to 30ths, what do I have? 10 times what on the bottom gives me 30. So then I multiply the top and I get 21. Agreed? So over here I have 15 times 2 gives me 30. So what I do to the bottom I do to the top. So 11 times 2 is 22. So when I add 21 and 22, 43 over 30. All right, what do you guys notice about B? 15/8 divided by 12/5. What do I have to do first? Keep, change, flip. Good. 15 over 8 times, and when I flip, I get 5 over 12. See if you can cross cancel. Are there any numbers that go into both 5 and 8? No. What about 15 and 12? 3? Okay, 3 goes into 12. 4. 3 goes into 15, 5. So if I multiply across, what's 5 times 5? 25 over 8 times 4 is? Perfect. Good. And then the last one, it's just multiplication. Can I cross cancel anywhere? Yeah. What number goes into 30 and 35? 5. 5 goes into 36 times. 5 goes into 35 7 times. Agreed? 6 times 12, anybody? 72. Good. And then 7 times 7? Perfect. Good. We good? Yes? No? Maybe? All right. Express the interval in terms of inequalities and graph. Okay, there's 2 things you have to do here. You're going to have to do both things on your test. If I express number 11 as an inequality, they're telling me the x values are in between what 2 numbers? Look at 11. What are the boundaries? What are the endpoints? When I graph it, I'm going to put a what and a what? Number-wise. -2 and 6. So sometimes we get a little confused when we have to write the inequality. Watch, guys. I know that -2 is the smallest number, and 6 is the biggest, and x is somewhere in between, right? You guys agree? Okay, so you can start out like that. You got a -2 here, 6 on the other side, and the x is in between. And then I know my inequality is going to go this way. But now I have to figure out, is there an equal to under either of the inequality signs? Which one? Yep, the one with the bracket, the one on the left. This includes, that means I'll have an equal to underneath. What does that mean for a dot when I graph it? Close. Good. So when I graph this, remember, I don't have to see every tick mark. I have to see 0, and I have to see both of your endpoints, and then you just leave it like that. So I'm going to have a closed dot at 2, an open dot at 6, and I do what in the middle? Color it. Shade it in. Same thing with 12. What are the 2 endpoints? 0 and 10. And x is somewhere in between, right? So write it like that. Then you have your inequality signs. Is there an equal to sign underneath either of the inequality signs? Yes. On which one? The one on the right or the one on the left?
Right.
Good. Very good. That includes, so when I have my number line, I have 0, I have 10, I have an open dot at 0, a closed dot at 10, and I color in between. Good. All right, let's look at this one. How is this one different? There's an infinity. This is saying that it's from -infinity up to 4. So let's graph that first. That'll be easier for us to write our inequality sign. Here's my 4. Here's 0, and here's infinity. What kind of a dot do I have at 4? It's closed, right? So I want all of the numbers that are what than 4? Less than or? Yep, you guys just told me what the inequality was. You want all the numbers that are less than or equal to 4. If I come over here, what is this one? What's my graph going to look like? Where do I put a point? -2. Good. Here's my 0. How do I graph this? Open or closed dot at -2? Closed. And I want all the stuff that's what? Greater than. So you guys just told me it's x is greater than or equal to what? -2. That's confusing. I know that. Those always get us every time we do that. If you graph it and then read it, you guys just told me, -2, I want all the stuff greater than. That's exactly what we did. We just said x is greater than or equal to -2. Sound good? All right, let's scoot. You guys know how to graph. We don't have to do those. I'm going to do 19 here. I'll work them all out and post this up, but I'll just do one of these. We need to remember, this sign means what? Union. That means I want all of it. All. I want all the stuff from A and I want all the stuff from B. This means what? Intersection. What do I want here with intersection? What they have in what? Common. What happens if they don't have anything in common? You put the 0 with the line. Perfect. So if I look at, let's do 19. I'll put it right here. The answer. So I want A union B. So I want all the stuff from A, and then I want all the stuff that's different in B. So write down all the stuff that's in A. What do we have? -1, 0, 1, 2, 3. Agreed? Now look at B. Did I already write the 1/2? So write it. Did I already write a 1? Yes. Did I already write a 4? So write it. There you go. What is B looking for? Intersection. What they have in common. So what do they have in common? Just a 1. Does that make sense? Good? All right, let's look at a couple down here. Absolute value is always what? Always positive. So if I did 24, 24 is a fraction problem. -3/2 minus 5. I'm going to put 5 over 1. Is that okay? Yeah? Makes it look a little better. When there's a whole number, put it over 1 so it looks like you have 2 fractions. Before I can simplify this, what do I need? I need a same denominator. What's going to be my common denominator? 2. So if this is 2, what does the 5 become? A 10. So I have the absolute value of -13 over 2. Agreed? What does that give me?
13 over 2.
13 over 2. That's it. Yesterday, Nathaniel came up and asked me about 27. He's like, did I do this right? I said, absolutely. Good job. Look at 27. What's another way I can rewrite 2 to the -3rd power? 1 over 2 cubed. Minus what? 1 over 3 squared. All this is a fraction, guys. It's 1/8 minus 1/9, correct? What's the common denominator between 8 and 9? 72. It's big, but that's okay. I multiply 9 on the bottom, 9 on the tops. I multiply 8 on the bottom, 8 on top. 9 minus 8 is 1, so it's 1 over 72. Stuff on your test is going to resemble 49, 50, 51, 52, those sorts of things. You guys just have to take your time. I will do 50, 52, and 58. I'll work everything out, like I said, later, and I'll post it. But just for right now, I'll do this. If I have something like 50, there's a lot going on in this problem. But if you follow the steps, it's not as difficult as it seems. If I have an exponent on the outside of a parenthesis, I need to distribute it inside. So I'm going to take this -3. I'm going to distribute it right here. That gives me a to the what? -6. If you raise a power to a power, you're multiplying. So now I'm going to take this 2, and I'm going to multiply it here, or distribute it here and here. So I have a to the 6th, b to the 2nd. Again, I know my b's and 6's look alike. Sorry. And I'm going to take this 4, and I'm going to distribute it, and it becomes what? b to the 12th. Now there's a couple ways to look at this. Some people, first period, said, well, immediately, I'm going to put this a to the 6th down here. That's fine. You can do that, and then that's gone, right? But if you kept it all on the top, that's fine too, because when you're multiplying multiplying bases that are the same, what do you do with the powers? When you're multiplying, you add them. So you would have said -6 plus 6 is what? 0. Here, I have 1 in the numerator, 1 in the denominator. What do you do when the powers are the same and you're dividing? You subtract. But what's going to happen? What's 6 minus 6? 0. What's anything to the 0 power? So it's going to just cancel out. So either way, it would have canceled. And then you're left with b to the what? 14th. When you have the same base and you're multiplying, you add exponents. Good. Okay, you look at 52 and you're like, oh my gosh, there's fractions. It's not bad. It's not bad. I'm going to say, all right, I got to take this 6 and I'm going to have to distribute it. So I have r to the 12th. Good. Then I have s to the, oh no, I have to multiply a fraction. No worries. 4 times 3, 6 times 1. Can I cross cancel anything? This becomes a 2. So 4 times 2 is 8. So it's to the 8th power over. The 6 goes here. So again, I have 6 over 1 times 1/3. Well, what does that give me? 2. So it's r squared over s. Agreed? All right, now do I have the same bases that I'm dividing? Oh, I forgot the 6. Thank you. Thank you, thank you, thank you. Do I have the same bases and I'm dividing? So what do I do with the exponents? Subtract. So what's 12 minus 2? So r to the 10th, right? And then s to the 2nd. Good. If you guys take your time, seriously, if you take your time and just very methodically, very cleanly, very neatly work these problems out, they're not bad. But some of you are just so all over the place that you get confused. So let's try and not do that. All right, let's look down here. This is another gross one, but it's really not bad. I have a power outside of the parenthesis. That means I need to do what to it? Everything inside. Distribute. So just take your time. A to the negative 2. Sorry. A to the negative 2. Agreed? So then this negative 2 goes to B. So I have B to the negative 4. And then I have C to the what? 6th. Over 2 to the negative 2, A to the negative 4, B to the 8th. Questions? We're good? Now, before you do anything to simplify, what should we do with anything that's negative? Make it what? Positive. So how would I do that? If anything's in the numerator and has a negative exponent, where do I need to move it? To the denominator. If anything's in the denominator and it has a negative exponent, where do I move it? To the numerator. So let's do that. So this a squared, I'm going to move it down. Agreed? So it becomes a squared down here. This b to the 4th, I'm going to move it down. It becomes b to the 4th. C to the 6th stays where? On top. So those are all done. Now this 2 to the negative 2nd is going to go up and become 2 to the what? 2nd. This a to the negative 4th is going to move up and become a to the 4th. And b to the 8th stays where? In the denominator. Does anybody have any questions about how I just did that? We're okay? All right, so if I simplify, what's 2 squared? 4. If I have a to the 4th on top, and a to the 2nd on the bottom. Same bases, what do I do to the exponents? Subtract. So this becomes a to the 2nd, and it's up here. Look at my b's. I have 4, and then I have 8. How many total b's do I have? I have b to the 4th and b to the 8th, all on the bottom. So how many total do I have? 12. So this is b to the 12th. It stays on the bottom. And then what about c? Just stays there, hangs out. That's cool. All right, so to rewrite this so it looks better, I have 4, a to the 2nd, c to the 6th, over what? B to the 12th. Okay, 2 more. You have the last 4 questions. There's 16 questions on your test, so the last 4. 2 are like 59, 2 are like 60. That should be an easy 20 points right there. They're 5 points each. If you are starting off with a huge number, you want it to be in scientific notation on 59. I have the number, looks like this. Where is my decimal point in this huge number?
After 59.
Well, that's for the number.
Okay.
Yeah, I see what you're saying. But where's the decimal point? It's at the very, very, very end. If I'm going to write in scientific notation, this first number needs to be between 1 and 10. You're always going to move it, guys, to between the first and second number. So I'm going to move this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Do you guys see how I now have 7.825 times 10 to the, how many spaces did I move? 10. That's it. That's all you gotta do. All right, here we're starting off in 60. We're starting off in scientific notation, right? Yes? Okay, so I have 2.08 times 10 to the negative 8. Which way am I moving if I'm going negative 8 spaces? To where? to the left. 1, 2, 3, 4, 5, 6, 7, 8. What do I do with all those spaces? Fill in zeros. If you guys are in scientific notation, right? We're in scientific notation here. And it's a negative exponent. That means the number is going to be teeny tiny. When you're in scientific notation, the exponent tells you which way to move. Negative is to the left, positive is to the right. Make sense? Okay, that's it.